Hello, my name is Anmol Kapoor, and I'll be talking to you about my project called Job Reaper. Here I'll start off with, because this takes some time, I'm going to start running the code, and then after that I'll talk to you about a bit about my project, and then I'll get back to the code. Okay, so I call my project Job Reaper. Essentially what Job Reaper is, it's basically a combination, it's kind of like uh, LinkedIn or Indeed, where companies can post their jobs, and anyone can apply to them. However, my ideology is uh, that posting jobs on both a on two separate job pages, like LinkedIn and their own careers page, that becomes very um, that becomes a very repetitive task. So essentially, with Job Reaper, all companies have to do is post their jobs, their job opportunities, their job listings on their careers page, and my project will essentially scrape their careers page for all the job listings and organize these into a website or a GUI. As stated, my project plan is to scrape each and every job board for job titles, their location, and the application link. I'm getting these application links from a gigantic Google spreadsheet, and there can be hundreds of companies in that Google spreadsheet. So there's going to be hundreds of um, algorithms, one for each job board. This is the thinking that I started off with. So from each job board, job title and their location, and place all the data into a SQLite database. And then from here, I'll display the results in a website or GUI format. This project plans works the fastest, scraping each job board for job titles, their location, their application link. That's not as, that's very quick. This is a very quick algorithm. It's not going to take that much. It doesn't take that much time. Maybe 10 seconds or so for each job board. For example, for job board 1, let's take a look at the Snowflake's job board. For example, for accounting manager, you see that's it's located in the div class opening. And that's basically what my algorithm here in the top left is looking at. So this is Python code to scrape the website, and it's searching for all divs with a class of opening. So div.opening as the XPath. And this algorithm basically takes care of gathering specific data from the job board. And then taking a look at job board 2. Job board 2 is very similar. Remember that I'm creating an algorithm for each and every single job board. So for HubSpot, that's what this job board is. I'm looking at all A tags with A is a link tag, basically, with a class of that random combination of letters and characters, and all the information is compiled in there. But this is a whole bunch of basically my algorithms are the same except for the class opening and class SCBD and so on. It gets very tiring to repeat this process for hundreds and thousands of numerous different job boards. It's very tiring, so I have to come up with some easier way, some universal algorithm for me to grab all the job information from a job board. Okay, so what I thought of was to use machine learning for natural language processing. Four very famous algorithms in the field are BERT, TF-IDF, Naive Bayes, and ERNIE. For this project, I chose to go with BERT because it seemed to be the best use for this project as opposed to the other three commonly used algorithms. Essentially what the BERT algorithm does, it takes a look at a phrase And looking at previously trained data, basically what BERT does, it takes a look at, for each phrase, the beginning part and the ending part of the word, and looking at the word frequencies in between. TF-IDF kind of works similarly. However, it takes a look at, it's more of figuring out which word is the most important, and works better when comparing different web pages. As for naive Bayes, classification by word probability, it's also a very famous algorithm. However, it's not as strong as BERT. In some ways, Ernie works better than BERT, but I still chose to stick with BERT. So my revised project plan flowchart, while I'm ending with a website with organized job listings from a custom list of companies, I'm starting with fine-tuning a BERT model on lots of data gathered over the summer from countless websites. After fine-tuning the BERT model, I scraped all the text from a company's personal job board. For example, when you're looking at, suppose the BERT machine learning algorithm, it's not perfect. So maybe it detects accountant, commission, and related accruals as a job title, but not accounting manager. Because my algorithm finds accountant, commission, and related accruals as a job title, it's going to look at similarly structured data, including accounting manager, commissions manager, and since it finds that data as since it found the first of that data as a job title, all the rest are also assumed to be job titles as well. And this is the plan. So it's been about 7 minutes after running this code, the scrape struct, as I explained earlier. For loading jobs from 3 companies, Activision, it took 370 seconds, Snowflake 11, and HubSpot 46 seconds. Finally, after updating the job postings, we can reload the web page, and you'll see all these updated job listings, all of those. Snowflake, same thing, Snowflake, and HubSpot as well. As you can see on the, there's a search for jobs. You can search for jobs specifically by keyword. For example, if you want to search for, suppose, engineer, you want to be an engineer, submit, and then you'll find a whole bunch of jobs from Activision, Snowflake, HubSpot, all of those, all the jobs that have engineer in their title. With any computer work that anyone does, it's always important to take a look at the drawbacks and successes. I came up with a list of drawbacks and successes. As for the drawbacks, one is the trained BERT model is not perfect or efficient. Some solutions and next steps would be to continuously increment the training data set size. This would be to fix problems where I would sometimes get career site cookie settings as a job title, but that's not really a job title. Or Call of Duty, that's not a job title. And then, I could also hard code some more expectations. Next, scraping time takes 20% of the CPU and 900 MB memory for some pages. This is specifically meant for some multi-paginated websites. One way to battle against this high memory usage would be to utilize some smart scraping algorithms for multi-paginated websites, such as, for example, when I take a look at, let's see, Activision. When I take a look at Activision's job board, what my algorithm is doing, it's scraping all the entire web page here, and then clicking on the second page, and then copying the entire web page again, not just what has changed. That could be one way I can go about, but that may also, doing something like that may also increase my CPU usage. Another drawback is, is that the Heroku website for this app is slow for the initial load. One way to combat this would be to invest in another website hosting platform like AWS. Another thing I can do is use install Diet OS on my Raspberry Pi to host the website, which wouldn't take too many resources. The UI is not perfectly friendly or worthwhile. I mean, of course, there are going to be some issues with the UI. I mean, the users can't specifically change the companies they want as of yet, but with more updates, that will become a feature. And next, I want to talk about successes of my current procedure. For example, the BERT model significantly reduced the scraping speed in a universal algorithm. Another thing that was a success is that the honing algorithm effectively reduced false positives. Another thing is that I was able to implement the feature to search jobs from all companies by a keyword in their title. And furthermore, there's protection from form field SQL injection. Another thing that was a success with my procedure is that this works with multi-paginated job boards. For example, with Activision, there's multiple pages, and it works for all of these pages. If I go to, I think there's like 30 or so pages, and so on. Furthermore, the web page loads in minimal time after the initial load. Initial load, that's due to the Heroku website. But after that, the SQLite commands, they run super fast, and the load time for creating the web page, that's very fast. This can also be accessed cross-platform, as in I can see on my phone, complete job applications through any device I want.